Alright, welcome back. Today we're going to talk about more composition of functions and then domain. So this is a really quick one. Just let's take a look at each problem here. I just want you to find the domain of 1 and 2. And if you guys want, pause the video and try to see if you could do this first. Now, domain restrictions are things x cannot be. So, first off, I see a square root of x here. Well, because I see a square root of x, I know that x cannot be negative numbers, because if I put a negative in there, I get an imaginary answer. So right away I know x has to be greater than or equal to 0. However, is that the only answer? What else makes the bottom 0? Well, we have this minus 4 here. So if this piece turned into a positive 4 somehow, that would give the bottom of 0, which we cannot have as well. What value of x gets a 4 out of that? So the square root of something is 4. That would be 16. So my final answer is the domain for this problem is that x has to be greater than or equal to 0, but it can't be 16, or else we get a 0 on the bottom. And that's it. This one you guys should be, you don't even, probably could just look at it and tell me. If you factor that, you get x plus 5x minus 5. And you get, so the domain as all x values that x cannot be plus or minus 5. That's an oldie but a goodie. So you guys should be good with that one. Now let's look at some problems here. And this is, I can't stress this enough, especially if we're dividing. But see how there's like square root of x's for number 3? If ever I ask you to divide on a quiz, I will ask you to not rationalize, which means for that one problem, it is okay to have a square root in the bottom. Just for that one problem. If there's ever a problem on a quiz that says do not rationalize, or a test, that means do not multiply the top and bottom by stuff to try to get rid of the square root. You are okay to keep that there. So let's add these together. So f of x plus g of x is 7 square root of x plus 11 plus 12 root x minus 10. So when I add those together, I have a 7 root x and a 12 root x, which is a 19 root x. And 11 minus 10 is a positive 1. Okay? We look at the answer. Again, it's square root of x is our domain restriction, which means that we can't have negative values. So my domain for this problem is x has to be greater than or equal to 0. Again, because of the square root. Number 4. Again, x to the 1/2 is the same thing as saying square root of x. So our domain restriction is x has to be greater than or equal to 0 for f of x. G of x, it's all real numbers. That was a weird R, so we'll just fix that. So let's see what happens when we do our composites. We do f of g of x. So we're placing g of x into f of x. So I have 4x plus 3 to the 1/2. Okay? Which turns into this. 4 square root of x plus 3. Alright, well my domain changed a little bit. Again, we can't have negative values in here. So, but let's say I put x as negative 2. If I put negative 2 in there, I get a 1 out, which is acceptable under a square root. So, negative 3 for x will give me a 0, which is also acceptable. So that means x in this case has to be bigger than, so this is my, by the way, f of g of x. And my domain is that x has to be bigger than or equal to negative 3, not 0, because negative 1, 2, and 3 also work in that problem. If I do g of f of x, again, this domain restriction is x has to be greater than or equal to 0. And let's see what we get. I get 4x to the 1/2 plus 3, which is 4 root x plus 3. Which, again, our domain restriction is the same thing, so x can't be, or x is greater than or equal to 0 because of the square root of just x. Okay. If we do number 5, the last one, I have 3x to the negative first. The domain restriction here, remember, this is the same thing as 3 over x, so x cannot be 0. Here, x can be all real numbers again, because it's just 2x. F of g of x, so 3, 2x minus 1 to the negative 1. That's the same thing as saying 3 over 2x minus 1. So in this case, the bottom can't be 0. What x value gives us that restriction? Well, if you set that equal to 0, you get 1/2. So my domain for this problem is x cannot be 1/2. And this is the answer. F of x. Let's see what happens here. We get 3, and then we input 3x to the negative 1, and then to the negative 1. Again, a lot of people forget to raise this 3 to the negative 1. So this turns into 3 times 3 to the negative 1 times x. Because x to the negative 1 flips it back, it's 1 again. Which is just 3 over 3x, which is the same thing as x. Okay? Now you might be looking at that and go, well, I can make anything x. However, you have to also look at the input. The input, the domain restriction is x cannot be 0. Therefore, my domain restrictions, x cannot be 0, even though this is the final answer. So always remember that with composite functions like for number 4 and 5, domain restriction has to be what you're inputting into the problem, if it's part of it, and then also the final answer. Okay, so that is all, and nice quick video.